Alum Video 2. First is crystal growth. So I still have not seen any crystal growth. There are a few really small particles in the tube, but they're hard to see in the images, and it's hard to determine whether or not they're small crystals or if they're just like dust particles. I think there are a few possible reasons as to why there are not any super visible crystals growing. The first is that the temperature in my room is usually pretty warm, and I know that solids are more likely to precipitate at colder temperatures than warmer, so there might not be any crystals growing because my room is so warm. The second reason is that the Kim wipe cover was pretty thick, so not enough solution would have been able to evaporate, so I unfolded the Kim wipe and then re-secured it with the rubber band so that more water will be able to evaporate next week. Next, theoretical yield. So for theoretical yield, I started with the mass of aluminum foil, which was 1.009 grams, and then I multiplied that times the molar mass of aluminum. And then I used the coefficient ratios from reactions 1 through 4 seen at the top of this picture to get to alum and the final reaction, and then I multiplied that times the molar mass of alum, and I got a theoretical yield of 17.744 grams of alum. Next is percent yield. So for percent yield is the actual yield over the theoretical yield times 100. And for this, I got the actual yield, my partner and I measured in the lab to be 20.026 grams, and I divided that by the theoretical yield, which was 17.744 grams, and I multiplied that times 100 and got 112.86%, which is higher than 100%, but a plausible explanation for that is that because aluminum foil is not pure aluminum, that possibly the impurities that were in the aluminum foil were not completely removed, and also the calculations were done with the assumption that the mass of the aluminum foil was pure aluminum, and it's not. So that would be a reason that maybe the percent yield is higher than 100%.